Hi everyone. In today's lesson, we're going to talk one last time about trinomials. So as always with this factoring flowchart, we're always going to try GCF first. If we then get something that has three terms, then we can use either AM or AC to factor. So today we're going to focus on trinomials that have more than one variable. We call these multivariable trinomials. So you could title today's video with Factoring Multivariable Trinomials. Okay, so we're just going to do two examples. Example number one says factor 3x to the fourth plus 15x squared y squared minus 108y to the fourth. So at first glance, this seems rather tricky, but if we follow the flowchart, it's really not as bad as we think. We're going to look for GCF first. Well, I see an x here and an x here, but I don't see an x here. So that means I can't take out an x out of all of them. I see a y, but no y here, so that means I can't take out a y. I see 3, 15, and 108. So I'm going to try to see if I can divide 3 into 108 because I know 3 can go into 15. So if 3 goes into 108, then that's going to be the GCF. So take a minute, pause the video, and see how many times 3 goes into 108, and then hit resume when you're ready for the answer. Okay, so you should see that it goes in 36 times. So that means my GCF that we're going to pull out is 3. We're going to divide all three pieces by 3, followed by an open parenthesis. First two 3's will cancel. We're left with x to the fourth. Now when I divide 15x squared y squared by 3, we just get 5x squared y squared. And then when I divide 108 by 3, we got 36. So 36, but now y to the fourth. So now the goal is going to be to factor this stuff here on the inside. So now that we have a lot of things going on with the exponents of the trinomial, we really need to remember the structure that I spoke about in the last video, that the middle exponents have to be half of the outside. So see how this x squared is half of this 4? That means we can factor it. And because this y squared is half of this 4, that means we can factor it. If this exponent in here, say, was a 3, we wouldn't be able to do it because it's not half of 4. And we'll show you examples like that later on, but that structure is important that we understand it. So let's put put the leading coefficient of 1. So since we have a leading coefficient of 1, we know we can use add multiply. So we still need to find numbers that add to 5x squared y squared that will multiply to negative 36y to the fourth. So with these multivariable trinomials, you don't have to do anything with the y's and the x's. All we have to do is do what we normally do. Go to the y equals and put negative 36 divided by x and look at the table of values. So why don't you do that, pause the video, and then hit resume, and we'll compare our answers. Okay, so 1 and negative 36, 2 and negative 18, 3 and negative 12, 4 and negative 9. Now we know this list can be repeated, so negative 1 and positive 36, negative 2, positive 18, negative 3, positive 12, and negative 4, positive 9. So we're looking for the pair on this list that's going to add to a positive 5. So I'm thinking it's either this one or this one. So let's do it. 4 plus negative 9 is negative 5, and negative 4 plus 9 is positive 5. So this is the pair, not that one. So we're going to do the same thing that we've been doing all along with add multiply. So we're going to put two parentheses, and in the front, we're going to break down this x to the fourth into x squared and x squared. And in the back, we're just going to break up this negative 36 y to the fourth. Now, we already found out that it's negative 4 and negative 9. So if this was just a 36, you'd put negative 4 and negative 9 here and here. But because there's a y to the fourth, we have to break that up as well. So we're just going to put in negative 4 y squared and then positive 9 y squared. So the 36 helps us with the numbers. This y squared we have to do by looking at what's here. Now you'll bring down your GCF of 3, and that will be your final answer. That is if there is no dots. But I think I see here is a difference of two perfect squares. So this can actually be broken down a little bit more. Breaking down x squared into x and x, that's going to go in the first parenthesis, and then breaking down negative 4y squared to negative 2y and positive 2y. So plus 2y and minus 2y. And we'll bring down our GCF of 3, and we'll bring down our x squared plus 9y squared. That is your final answer. Remember, this here is not dots. It's not a difference of two perfect squares. It's a sum. All right, let's try another example. We'll call this one example number 2. Directions are the same. Say to factor. So we've got 16 y to the 12th minus 32 y to the 6th r to the 2nd plus 7 r to the 4th. So just like normal, we're looking for GCFs out of all three terms, and we're looking at the structure of the trinomial. So it looks as though that this 7 kind of makes dividing by a number more challenging, right? These are even numbers. So I don't think there's going to be a GCF with the numbers. And I only have y's here. I only have r's here. So it looks like there's no GCF. So you have to recognize the structure. With the y's, is this exponent 6 half of this one, 12? Yes. Is this exponent of 2 half of this exponent of 4? Yes. So the trinomial is factorable. So now we have to look at the leading coefficient. The leading coefficient is greater than 1. So we're going to have to use the AC method. So we're going to multiply the first and the last. So 16 times 7 is 112. So we have 112 y to the 12th, r to the 4th. And we want to find the pairs of numbers that will multiply to that, but while simultaneously add to negative 32. So I know we've got all these letters, but we're still doing the same thing that we do with AC. So we're going to go to the y equals, and we're going to put 112 divided by x. And we're going to look for the pair of numbers that look like they add to negative 32. So why don't you take a minute, pause the video, try it, and hit resume when you're ready. Okay, so I got that negative 28 and negative 4 will add to negative 32. But we know that it has to multiply to y to the 12th, r to the 4th. So what we need to make sure we do is just put our y to the 6th, r squared, y to the 6th, r squared. Remember, it has to match whatever those exponents are. So negative 28 y to the 6th, r squared, minus 4 y to the 6th, r squared. And then we're just bringing down our 16y to the 12th, and we're bringing down our 7r to the 4th. And we're going to factor by grouping. So we'll group the first two terms, find a GCF, group the second two terms, find a GCF, and bring down the sign in the middle. So of the 16 and 28, the GCF there is 4. And I believe you can take out y's as well. So 4 between the numbers, but y to the 12th and y to the 6th, I could take out the lowest exponent. So 4y to the 6th can be divided out of both of those. So if you divide this by 4y to the 6th and divide this by 4y to the 6th, 16 divided by 4 is 4. Subtract the powers for the y's. 12 minus 6 is 6. 28 divided by 4 is 7. The y to the 6th cancel, and you're left with r squared. The GCF of the second two terms, between 4 and 7, there's no number in common, but I can divide out r squared, right? The lowest exponents of the r's. So I'm dividing out an r squared, but remember that I took down the negative, so I'm going to divide by negative r squared. So negative 4 divided by negative 1 is a positive 4. R squareds will cancel, and you'll be left with y to the 6th. And then 7 divided by negative 1 is negative 7. And then r squared divided by r to the 4th, or other way around, is just r squared. We subtract the powers. So remember, the GCF, if these two are the same, which they're supposed to be, they get their own parenthesis. So 4y to the 6th minus 7r squared. And then the outside numbers, the 4y to the 6th and the negative r squared, get the other parenthesis. And always at the very end, we're checking for dots, which is difference of two squares. Well, these are both subtraction signs. 4 is a perfect square, 7's not, so this one's done. So we'll leave this one as 4y to the 6th minus 7r squared. This one, 4y to the 6th and r squared are both perfect squares, even exponents. So we'll just break down this one into 2y to the 3rd and 2y to the 3rd. And then we're going to break it down r squared into r and r. And then your plus and your minus. And this is your final answer, with this one being dots. All right, that's it for today. Take a second and jot down any questions that you might have, and we'll go over them in class tomorrow. Have a good night.